Hi, this is Kevin. Welcome to the tutorial for exercise 3 on chapter 8 of the Zelle 3rd edition Python book. And just like we did for 1 and 2, we're going to be looking at one of these demonstration programs that I provided in the weekly schedule. And this one is called 10 searching using whiles. We're going to be working on the searching use case for while. Okay, and again, I'm going to open it up with just a regular old text editor, and I'm going to build it into my PyCharm, and I'm thinking that kind of thing is going to work well for you as well. Okay, so we're going to have to create a new Python file, and this one is called _10 searching using while, and at least this isn't too long of a name. That's a good sign. Okay, we're gonna bring that over. Okay, so let's take a look at the doc string. Let's see what this thing purports to do. Okay, it says demonstrate searching using while. In this case, we're going to be searching in a file. Okay, we could have done it, I guess, in a list, but the tougher case is to do it in a file, and the while is going to allow us to do that. So it says search as input file for a line containing 3 matching integers. Okay, that's good. All right, now it turns out that in these Python projects that we have, we're keeping our data in a subdirectory called data. It doesn't have to be called that. That's just what we decided to call it. So now I'm going to have to create a data subdirectory. And it turns out that this uses three of the starter files for this. One's called empty file.txt. Another one is called 3values.txt. And then the last one is called tricky 3values.txt. Okay, so let me set that up. I'm going to create a directory called data. Again, that's not a magic name. It's just what we decided to call it in our class. And I'm going to copy these. At least on Mac OS, I think I can do 3 at a time. I'm going to highlight empty file, and then I'm going to click command highlight 3 values, and then tricky 3 values, and I'm going to right click and say that I want to copy. And I think I can come over here to right click on data and say that I want to paste. And as long as I keep saying okay, I'm going to get my 3 data files over here. Good. All right, so let's get back to what we were doing before we worried about the data files. Oh, here we are. So here's the program, and it's got the doc string. That's fine. Let's bring over the beginning of the code. So I've got the header for main with the def, okay. And let me bring over the end of the code too. Okay. Which is the call to main and empty line beneath it. We need that at the bottom to have a proper program. Okay. Okay. Now, one thing I want to point out in the example programs that I've given you to download, I've got some comments. And the comments are there to remind me to make points while I'm teaching. Not really things that I think that you would want to put into your own code. For instance, here at the bottom of all this initialization, we have a comment that says that this read is a priming read. Well, we know it's a priming read. Most programmers are going to recognize it as such. So I put that comment there to remind me to make a point of it while I was teaching, not so much to say that I was expecting you to put that comment there in your everyday programming activity. All right, so let's look at what we have here. We've got a pretty basic in our course so far, when we've been working with files, either an input file, an output file, or one of each, we've kind of taken the approach that we have a variable that holds the name of the data directory, or more accurately, subdirectory. Okay. We prompt the user for the name of the input file into in-file name, and then we build up this in-file path and name using an F string, and then when we do the open, we use in-file path and name, and here we're using the function code R to say that we want to read. Okay. We're counting the lines because we're going to want to say how many lines we read while we were searching. You can see that I've created a Boolean variable here called match found, and I've made it equal to false. Okay. And then I've done a priming read. Okay. And again, when you're working with these while loops, to process files. And, you know, we've been processing files so far. We've been doing prompts at the console, but the console is a file. It's just one that we don't have to declare and open. Okay, so we've been using files. Okay, and now here we have a file that we have to sort of explicitly define and open, but this is how we do a priming read. Okay, this is how we read a single line of a file that's on the disk. We use the read line method of the file object. All right, so let's start looking at some more code here. All right, so I'm going to bring over a bunch of code all at once, and then we'll take our time walking through it. Okay. All right. So what's going on here? Okay. So the thing to remember is, you know, whenever you're searching through files, you want to kind of understand the file that you're reading. Okay. Now, one of the files that we're going to read is this empty file. Okay, we just want to make sure if we get an empty input file that we're going to behave okay. That's not surprising. But let's look at this 3values.txt. Okay. Now this is a big file. When I double click on it, it tells me that it can't do code insight features because it's big. This has 1 million lines. So if you pull all the way down to the end of this, you'll see the last line, which isn't really here, it's just the end line on the one before, is the 1,000,001st line. Now, why did I make this file so big? Well, I wasn't sure. What I have here on each line are 3 random integer values between 1 and 1,000. And I wanted to know how many of those I had to generate before I got a line that had the same value for all three. So that's what we're looking for. We're looking for a three-way match. As it turns out, it was a pretty high number, but it wasn't a million. Oh, okay, but I generated a million records just to make sure we'd get a hit in there. And we did. And I generated it several times, and I always got a hit. So the law of large numbers being what it is, three of these integers between 1 and 1,000, if we generate enough lines, we're probably going to get a three-way match. And you'll see where that's going to match. Okay? Okay, and I kind of wanted, the other reason I made this big is I wanted you to see that there's a real advantage to being able to stop reading the file early. We definitely don't want to use a construct where we're going to be expected to read all the way to the end if we have hundreds of thousands of lines. And again, here we have a million lines. Okay? And a million of these lines adds up to 15 megabytes worth of data, which is pretty reasonable, I'm thinking. Okay, so we're going to read the lines, okay, and we're going to consider it a match when all three values are equal to each other. Okay, we're just going to keep reading along, all right? All right, so what are the conditions that we put on the while? Now, here's where we begin to use some of the fancier things in from the textbook. Okay, this isn't just a single expression that we're trying to use on the while, it's a double one. And I've done a further kind of a trick here, whereas I don't put up on here, I don't say while not end of file and then not a three-way match and try to express the three-way match. Okay, what I've done instead is, if you look, if you peek down here, and again, I've got a three-way comparison. I say if I get the values into three variables, first, this, second, and third. And I actually do a three-way comparison, which I always frowned upon, but I've decided a three-way comparison on an if is okay if we're comparing three things that are supposed to be exactly equal. So I'm taking that out of there. That was just a teaching point that I don't need there, right? Okay. And so what I do is if I have a three-way match, I turn a variable to true, match found to true, okay? And then I act on the match found, and we'll get to that in a minute. But what I'm really looking for is I'm saying I'm going to go until while line is not equal to the empty string. Line will be equal to the empty string when we come to the end of the file. Okay. If we read that empty file, okay, we would sense that right after the priming read. Okay, so we would never do this block under the while. Why? Well, because line is not equal, line is equal to the empty string. That's how we get signaled the end of file. Okay? And I could have had a much more complex expression up here, but I simplified it by taking this first equal second equal third and replacing it with a kind of a logical proxy called match found. And now it reads like a children's book. It's saying while we haven't reached the end of file and we haven't found a match, keep going around in the loop. Okay, so what do we do in the loop? Well, we want to keep track of the line count because we want to be able to report the line on which we found a match. And you're going to see the line on which we find uh, 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 the match of the three integer values. It's pretty high. It's nowhere near a million, okay? But it's big, okay? So we bump up the line count because we have a proper line, okay? We do a split, all right? Because we want to separate the three values. So this becomes a list of strings, which I call values as string, okay? And now I need to convert three values. Now I had a version of this where I had two values, and I just converted each of them in turn. As soon as I get three things in a list, and I've got to do the same thing to all three, well, I'm just going to put it in a loop. So I create a list to hold the converted values. I call it values instead of values as string. And then I just have a loop where I say for string value and values as string, values append, and I convert the string value to the integer. Now, I don't know if we've really talked about append a lot before. We'll talk about it quite a bit when we get to chapter 11, but that's how we programmatically add an item to a list. Okay, so we're converting each of these to an int and adding it into the list. So we started out with a list of three strings, and when we're done, we have a list of three ints. And then in order to make the code read really well and not having to refer to index values, I unpack that list of ints. I know I have three, so I am unpacking into first, second, and third. Okay. And then I ask the question, if first equal second equal third, if I have a match, well, then I turn on the indicator for match found. Okay. And then I print what I have to do for to tell the user that I found a match. So again, I use an F string so I can be really pretty, and I say I skip a line and I say three matching values of first. Okay, these are all equal, so I just picked one. Were found on line, and then I have line count. And you'll see I've done an interesting thing here. And again, this is maybe the first time we're doing this. I have a colon and then I have one formatting character, the comma. So this is going to, again, the line count could be pretty high. It could have been as high as 1 million, right? And so it's hard to read those things without the comma separators. And just by putting this comma here, I said, print the number with comma separators. And then again, because this is a count and it's integers, it's okay to end the sentence with a period. Oh, now, one thing that I don't think I've really expressly said is when I set the variable match found equal to true, okay, then I can test it by just using its name. So if match found is equal to true, then if I test match found, it's the same as saying match found equal true. If I say not match found, it's the same as saying match found equal false. Okay, it's a nice feature of the way the syntax works for Boolean values, and it works this way in a lot of programming languages. Okay, so if I haven't found a match, then I'm at the end of the loop, And you remember what we do at the bottom of these things at the end of the loop is that we just read the next line, okay? Now, it turns out I had a version of this program that I've been showing to students for a long time that had a very subtle bug in it that I thought about in the last couple of days, and I found it is uh, uh, one would think that the way to do this, okay, is to just have code that reads like this, right? Okay, we're at the bottom of the loop and we do a read line. Here's the problem with that. If you found your match on the bottom of in the very last line of the file, okay, well then you have a match and you haven't reached the end of the file, okay. The code that we're going to have later, it reports whether or not we succeeded on the basis of whether we've reached end of file or not. So if we just read the next line, we'll come to end of file even when we found it. Okay? And it's easier to just not have that bug. So we need to put this read at the bottom of the loop has to be on an else here. And I say placing this read in an else prevents accidentally triggering end of file. Now, how did I think of that? Well, I didn't think of it real soon. I had that bug in the program for 3 years. Okay, how likely, if you're going to generate these things randomly, and there's a million lines, how likely is the match to end up on the last line? Well, not real likely, but it'll happen sooner or later, right? Okay, and of course, in the 3 years that I had the other example, it didn't happen because we're always reusing the same data. But I just happened to be thinking through this and said, I think there's a bug here. And again, I put this comment here, not because I think you need it in your program, but because I had a teaching point. Okay? All right, we're almost done. We just need to finish up the program and do a little bit more reporting. Okay, so let's copy the code over, skip a line for drama, bring it over. Okay, so when we're done with the while loop, we've got one of two circumstances. Either we found a match before we reached end of file, or we reached end of file without finding a match. This refinement that we put here prevents us from confusing those two. So in any case, we're done with the input data. So we're going to close the in file. And then if we found a match, we've already reported the match. So we just have to be able to detect if we never found a match, which means that we came to end of file, which means that line is equal to the empty string. Well, then we want to be polite and say that we didn't find a match. So we print no matching values were found in line count lines. And again, we've got, after line count, we've got a colon to say that we've got formatting characters. And we just have the comma here because we want to include the comma separator. Okay, that's it. Let's do some testing, okay? So I'm going to run this. And what I usually do is I want to do my testing with the empty file right away. That should be something that's really easy for the program to handle. So we type in empty file.txt. We got no matching values were found in 0 lines. Okay, that seems pretty reasonable. All right. Now let's do this three values.txt. Remember that has 1,000,000 lines. That's a lot. So we're going to run it again. Three values.txt. And you saw it pause just a hair there. So three matching values of 896 were found on line 216,323. Wow. So that's about how long that takes. Now, I generated this a couple times. I got one that was really low, like well less than 1,000, and I got one that was really high, close to 1,000,000. This one, I think this was about the third or fourth that I generated. I thought that this gave you some idea that you might have to look through a lot of lines, but certainly not all 1,000,000 of them. Okay, we read that many lines and then we closed the file. We didn't read the rest. Okay, now what about tricky values? Okay, well, let's just look at tricky three values.txt. So here's one. I just went into the file and I snipped out the 10 lines right before the match. Okay, so now I've got a short file where we can kind of see it and understand it. If you wanted to play computer and walk through this, you could. Okay, and our match is on the last line. Now it looks like there's a line 11, but as I say, it only looks like there's a line 11 because we have a new line, a character at the end of line 10. We're ready to start line 11. We don't have a proper line 11 yet. So this is a match on the last line. Okay, now, right now, our code works for this. So let's run this, and let's call it tricky, not tracky, tricky three values.txt. And it says three matching values of 896 were found on line 10. Well, that's perfect. Okay, now I'll leave you to experiment if in fact we went back to our code, okay, and this final read that's at the bottom of the loop, we're not on this else, we would have printed the line that said that we found it and also the line that said that we didn't find it. Okay, and some people would try to say, oh, I'm not going to worry about that. I'll patch it up down here. Like if, line this and not that or whatever. I think that the design I'm giving you here is the simplest one. Okay. So there you are. All right, we got all three to work. Empty file, three values, and tricky three values. And again, three values, we're reading a file with 1,000,000 lines. And we're finding it after 216,323 of them. And look at that beautiful comma separator there. Wasn't that nice? Okay, that's all done. So you're going to do your own similar but not the same program, and I'm going to say bye until next time. Bye-bye.